Hey guys, Mr. Smith here. I'm making this video because I'm not going to be in class on Friday, March 13th. I've got some personal stuff going on that I need to take care of. So I didn't want to just leave you to do the work by yourself, so I'm going to make a video to kind of help you through it. So on Wednesday, we went through a PowerPoint about searching and sorting algorithms. Some of y'all were not here, so if you were not in class on Wednesday, you definitely need to start with the teacher slides here. And on the teacher slides, you need to download them and kind of look through the algorithms. The big thing, I know this is a ton of slides because of the way I make these PowerPoints, but the big thing here is, you need to go in and review linear search, and then also binary search, and then once you've done that, there's two sorting algorithms. So linear and binary we've talked about, but the two sorting algorithms are bubble sort and insertion sort. So definitely take some time to look through those. All right. Once you've gone through the PowerPoint and kind of refreshed your memory on that, we need to take care of formative number one, which is searching and sorting. So I've got it pulled up over here, so let me get that up for you guys. So what it looks like is this. So this is the searching and sorting in Python formative one, just to kind of practice. All right. So for the example below, use the linear search algorithm to the left. Determine how many times the if statement will check if the condition is true before the method returns a value. So if this is our list, 3, 4, 5, 6, 7, 8, 9, we're going to pass in a 5 here. So see that this is 5. You're passing in a 5. And, well, I guess technically we're passing in our list and our n here. So what we're going to do each time is we're just going to check it. It's linear, so it works from front to back. So it's going to check it at 3. It's going to check it at 4. And it's going to check it at 5, and it will find the 5. So the answer to this first one's pretty easy. It is 3. All right, so again, you're passing in this list, you're looking for 5, and you just work front to back. So you look at 3, then 4, then 5. All right, so you should be able to do these other ones pretty quickly. So second thing here, now we're going to do binary search, which is where you take the index of each one. All right, so if this is our list and we're looking for 5, right? We're looking for 5. So we're going to come here. This is at position 0. So just to kind of remind you, 3 is at position 0. Let me get back over there. 3 is at position 0. And then the 9 is 0, 1, 2, 3, 4, 5, 6, position 6. So the 9 is at position 6. So what we do is we add these two together and then divide. So 0 plus 6 is 6. So 6 divided by 2 is 3. So we look to see what's at 3. 0, 1, 2, 3. At 3 we find 6. Okay. So this is our first iteration here. So that was first iteration. So we find 6. 6 is greater than 5. All right, so that means we are going to take this now. So we're at position, so we redo our positions. 3, so we're working on this. Let me highlight it. We're working on this area. We're at 0, 1, 2. So then we go 0 plus 2 is 2, divided by 2 is equal to 1. So now we look at this. So at position 1 is 4. Position 1 is 4. So is 4 less than 5? 4 is less than 5. So now we're looking here. So this was our second iteration, iteration 2. And then on our third, we will just look at the 5 and find the 5. So it actually iterates 3 times, all right? So on the third if statement, right? So we're talking about the if statement. So it's 3 because we checked the if one more time. All right, so it technically does the binary search twice, but then we go back to the if statement one more time, so the answer there is 3. All right, so I want you to work through these also. So on this next one, place the following big O notations in order from most efficient to least efficient for a list with 10,000 values. So basically, we looked at a chart the other day, and this goes in order of efficiency. So if you go to the internet and you say big O notation ranked off efficiency, all right, it's going to give it to you in order. So big O of 1 is always the most efficient. Big O of log n is next. Then it's n log n squared, 2 to the n factorial. All right, so basically you need to take this information to fill in the order here. All right, or sorry, I think I said it backwards. We want to go from least efficient to most efficient. So that means that least efficient here is the big O of n. And you're going to work your way towards whatever the one that is the most efficient. All right. So again, if you just Google big O notation ranked of efficiency, all right. Yeah, wait. Oh, sorry, I was right. So from most efficient, I think I've said it wrong twice now. We want to go from most efficient to least. So the most efficient, oh my God, I even put the wrong thing. Most efficient is big O of 1. Sorry guys, it's early. It's like 7:30 and I'm making this video. Big O of 1 is your most efficient, and you want to go to your least efficient, which on this list is your big O of n factorial. All right, big O of n factorial, which is not one of our options. So that one should be pretty easy for you. So I'm not going to do 4, 5, and 6 for you. These are just multiple choice ones. They should be pretty quick and easy. Okay, when you finish this, I would like for you guys to then move on to the lab. All right, so I know I'm not there, but I would like for you to do the lab because it's very quick and easy. All right, so let's take a look real quick at Infinite Campus. So if you go back to your modules here, the lab I'm talking about is right here. It's March 14th. This is the day that I'm not here. So let me actually go in here. You have a substitute teacher. All right. So on this day, I want you to work on the searching and sorting algorithm. So you're going to click on this, and you're going to click here to download it. And basically, you only have 2 problems here. And you are writing the 2 methods. Or I guess you're writing a couple functions for number 1, and then for number 2, you're going to do a couple functions. All right, so for number 1, in this program, you will write 3 functions defined below. A function called count starting letters, which takes a list of strings and a single letter as a string, as its parameter. The function should return the number of strings in the list that start with the given letter. All right, so here, for example, if I were to call starting letters, I pass in my list and I'm looking for a T, and it should tell me that there are three words that start with T. So tigers, turtles, and tree monkey all start with T. All right, so your job is to write that function. So if I were to write it, I'm going to write this one with you. I'm going to do the first of each one. So if I were to write this, I would define it first, and I would say count starting letters, right? And then we're going to pass in a list and a letter. So that part's pretty much given to you because of the example call here. So at this point, basically you need to start with your count, right? Because we're counting starting letters, so we need to start with count. So now we need a loop. So for each word in our list, because we want to look at each word. Our list is called my list. We want to look at lions, then we want to look at tigers, then turtles, then leopard, then elephant. So for each word in the list, if the if the word at 0, is equal to the letter. So basically, word at 0 gets you the first letter. So it takes the word and it finds the letter that's at position 0. So that's lions, or L for lions, T for tigers, T for turtles, etc. All right. If they are equal, then all we do is increase our count. So count is equal to count plus 1. And then when we're finally done, we return the count. All right, and then that's it for part 1 of number 1. So that is count starting letters. You're going to do the same thing for count ending letters. All right, and you're going to pass in a list and a letter, and then you're going to fill it out. And then part 3 is you're going to now go in and a function called find word, which takes a list of strings and a word parameter. The function should return where the word is located. So you're going to find where the word is located in the list. So find word, list, and word. All right. So all we're doing is we are searching here. All right. We are searching and we are figuring it out. So I'm going to let you attempt those two. When I'm back next week, we'll kind of go through these together and make sure y'all got them right. All right, last one here on the lab is you're going to be writing 2 functions, one using the bubble sort algorithm and one using insertion sort algorithm on a list of strings. These functions should sort a list and then return the sorted list to be printed, and it should also print off how many times a swap has been made. All right, so for this one, guys, if you go look in the PowerPoint, you will find the actual algorithm for bubble sort and insertion sort. All right, so all you need to do is you're going to define bubble sort and pass in a list, and then afterwards you're going to do insertion sort and pass in a list. You are going to, if you go in the PowerPoint, you will find the algorithms for both of these, but you have to add a couple things. You need to add a print statement for how many times there was a swap, and you need to add a print statement for, or you need to return the printed list. So you need to return the sorted list, and print how many times it swaps. All right, I'm not going to do that for you. We'll go over it on Monday. So just, I want you to give it your best shot on these. You should be able to do these pretty easily. Again, in the PowerPoint are both of these, and you just have to modify it to add these 2 things. All right, guys, if you have any issues, feel free to shoot me an email or a Canvas notification, but otherwise, I really appreciate it if you guys would lock in and take care of this. All right, I'll see y'all next week. Have a good Friday. Have a good weekend.